So welcome to 8.7, day 2 of Pythagorean Theorem. So the Pythagorean Theorem states that if you sum the square of the legs, right, if you sum the square of the legs, that will equal the square of the hypotenuse. And I wrote it that way. So you have to identify in each one whether a hypotenuse is missing or a leg is missing. So in number 1, a hypotenuse is missing. So we're going 15 squared plus 20 squared equals, I'm going to use h for hypotenuse. 15 times 15, 225. 20 times 20, 400. And add those together, you get 625. 625 equals h squared. H could be 25 or negative 25 according to the math, but the length of a side, whether it's a hypotenuse or a leg, can only be positive. So we discard the negative solution. One on the left, a leg is missing, and so we have 15 squared is 225 plus 225. 25 squared is 625. Subtract 225 from both sides. L squared equals 400, and so the length of the leg has to be 20. These are in fact the same triangle spun around. You notice they have sides 15, 20, and 25. Now, most right triangles do not have whole number sides. So in this example here, the triangle side is the square, positive and negative square roots of 51, right? And the positive square root of 51, if you use a calculator, is this irrational number, 7.141428429, that goes on forever, which we could either leave as the square root of 51, since that's simplified, or we've been approximating them to the nearest tenth, approximately 7.1. Most right triangles have at least one of those. Okay, so that's what's going to happen today. So we're missing a hypotenuse. So we're going to go 4 squared plus 7 squared equals hypotenuse squared. 4 squared is 16. 7 squared is 49. 49 plus 16 says 15, 65. 65 equals h squared. So h will equal the positive and negative square roots of 65. And it says round your answer to the nearest whole number. Well, that's nice and easy because square root of 64 is, so I should be using an approximate symbol here, is a little more than 8, and it's an irrational number a little more than 8, and so it rounds to the nearest whole number, 8. So this is approximately 8. It's actually a little bit more. Rounding your answer to the nearest tenth this time, right? So what's missing, a leg or a hypotenuse? A leg is missing, so we're going to do L squared plus 10 squared equals 12 squared, right? We're going to subtract 100. 10 squared is 100 from L. I'm going a little too fast. So L squared plus 100 equals 144. Subtract 100 from both sides. L squared equals 44, so L equals the positive and negative square root of 44. Round your answer to the nearest tenth. All right, so square root of 44 is between the square root of 49 on the high side and square root of 36 on the low side. It's 5 away from there, and it's 8 away from there, right? So it's closer to 7, right? It's between 7, it's between, between 6 and 7, but closer to 7. All right, so I'm going to say 6.7. Let's check 6.7 out. 7 times 7 is 49. 7 times 6 is 42. 46. 7 times 6 still 42 in the second row. So 6 times 6 is 36 plus 4 is 49. 8. I'm getting 44.89. That's a little high. Should I check 6.6? All right, we'll check 6.6. 6.6, 6 times 6 is 36, then plus 3 is 39, it's 36, 39, 6, 15, 4, 13, I'm getting 43.56. Oh, 6.6 was slightly closer. So it's approximately 6.6. Find the exact length of the missing side. Well, we've already done that. What was the exact length? Positive the square root of 44. But what's wrong with the square root of 44 as an answer? Not simplified. It has, right? You have to look to see if it has one of the numbers from the perfect square list as a factor. And it does. It has square root of 4. So we simplify that, and it's 2 times the square root of 11. Remember, squares and square roots of numbers cancel each other out. All right, so let's see this. All right, what are we missing here? We're missing a leg, right? The longest side here is 7, right? Square root of 13 is, right? Square root of 16 is 4, right? Square root of 13 is less than 4. The longest side is the 7, so that's our hypotenuse. Our hypotenuse is always opposite the right triangle. So we're going to have L squared plus the square root of 13 squared equals 7 squared. Square root of 13 squared, those cancel each other out. L squared, L squared plus 13 equals 49. Subtract 13 from both sides. L squared equals 36. Oh, L equals 6. So the side was 6, right? Which is the longest side? The 7, right? Square root of 13, right? Around 3.7. I'm just guessing because square root of 16 is 4. Right, so what's missing here? The hypotenuse is missing. So it's 5 squared plus the square root of 39 squared equals h squared. 25 plus 39, because those cancel, equals h squared. 39 plus 25, I'm feeling like that might be 64, a perfect square, and so it is 8. Okay, if you've been doing your homework and all these lessons, you've been noticing the same answers keep coming up over and over again. There's a reason for that. It's because that there are only a few of these triangles with whole number sides. So it turns out if I take the 3, 4, 5 triangle, which we've seen several times, and we multiply each one by 2, we get another, and multiplying each of those numbers by 2, I get another right triangle. And if I multiply them by 3, 4, a million, I get another right triangle. 6 squared, 3 squared plus 4 squared equals 5 squared. We've seen many times. 6 squared plus 8 squared equals 10 squared. Come up with some more right triangles. Right? So if you multiply by 3, right, we get 9, 12, 15. If you we've done that one. If you multiply by, I'm taking the first one and multiplying it by 4, you get 12, 16, 20. We've done that one. But you can be more creative, right? You can multiply by 10, 30, 40, 50. All of these satisfy Pythagorean theorem. You could multiply by, obviously, 1,000 and go 3,000, 4,000, 5,000. Right? If you go 3,000 squared plus 4,000 squared equals 5,000 squared, it does. And you can get more creative than that. Okay, this is there. Any time all 3 sides are whole numbers, it's called a Pythagorean triple. All right, so now we're going to do the Pythagorean theorem backwards. This is called the converse. And what it is I drew this as a right triangle, but you're going to prove it is a right triangle because the Pythagorean theorem works forwards and backwards. Now, not all theorems work forwards and backwards, but this one does. It has a converse. And so let's see that. So now, one of the things you have to realize is, even without the picture, you should know that 21 is our potential hypotenuse. Now, it's a potential hypotenuse because we don't know this is a right triangle. Right? So this is 12 squared plus 16 squared equals 21 squared. If that turns out true, then this angle over here has to be a right triangle. And if that math does not work out, it can't be. All right, so let's see that. 12 squared is 144. 16 times 16, we haven't done that one that many times. It is 256. And 21 times 21 is 441. All right, so then you add 144 plus 256, and I'm getting 400. I'm getting 400 equals 441. All right, so that's no. Is this triangle a right triangle? No. And this can't be a right angle. None of them can be a right angle. This must be some other type of triangle, acute or obtuse. All right, so let's try this one. We've done all this math, basically. 12 squared plus 16 squared equals 20 squared. We just did this side, and we get 400, and 20 squared equals 400. Yeah, this is the one. If you have 16 and 12, right, as your legs, this side must be 20. But it's even more powerful than that. If I go and give you two sticks that are 12 inches long and 16 inches long, and a third one 20 inches long, I give you those three sticks and I say make a triangle out of them. That triangle will be a right triangle. Won't be any other kind. Period. Has to be a right triangle. If I say I give you sticks, but I make one of those sticks 21 inches or even 20.2 inches, and say you get $1 million if you can make them into a right triangle, you won't be able to. There's no maybe in this, right? Right? The three lengths either exactly make a right triangle or they don't. Right, so let's see that now. Which is the longest side? Which is our potential hypotenuse? Hopefully you're saying 10, right? Because the square root of 19 is, right, square root of 16 is 4. So this is a little bit more than 4 that we're squaring there. And so square root of 19 squared is 19, because those cancel. 9 squared is 81. 10 squared is 100. 81 plus 19, that looks like it's going to be 100. 100 equals 100. Yeah, that's exactly a right triangle, square root of 19. Now, right, that side is an irrational number that goes on forever. But if it's exactly the square root of 19, then this will have to be a right angle right there, opposite the longest side, and that will have to be a right triangle. Okay, you can actually tell from the math whether the triangle is also acute or obtuse. So let's see that. So 6 squared, right? So the long side is 12. 10 squared equals 12 squared. 36 plus 100 equals 144. I'm getting 136 equals 144. Well, that's not true. 136 is less than. And when you get now you have to write it like this, but if you get the less than there, if the leg side is less than the hypotenuse side, that is obtuse. Okay, so what does that mean? I drew that like a right triangle, but it's a false picture because really it actually bends out like that a little bit and looks more like that. It's an obtuse triangle. Do that again. So the long side is the 9, so it's 6 squared plus 7 squared equals 9 squared. You get 36 plus 49 equals 81. 36 plus 49, 15, 85. You get 85 equals 81. Now 85 is greater than 81. What does that mean? It's acute. Okay, and that means this actually is a false picture. That's a little severe, but this angle here, it's not that severe. All right, there you go. This angle here is less than 90 degrees, more closed than 90 degrees. This must be an acute triangle where all of these are less than 90 degrees. All right, let's practice. All right, so in 3 dimensions, hopefully you're looking at the side of this box, and you see that this side is 7 centimeters and this is 5, and we're trying to find that one. So those are legs. 5 squared plus 7 squared equals hypotenuse squared. That's 25. That's 49. 25 plus 49. That looks very familiar. Oh, no, it isn't. 25 plus 49 is 74. And so, yeah, 74 equals h squared. All right, round to the nearest whole number. I should have known better. And so this is the positive and negative square root of 74. All right, so square root of 74, I got to round it now. So I got square root of 74, I got square root of 81, I got square root of, that's 9, 64. That's the one I thought it was going to. 10 and from there, and 74 to 81 is 7. So it's a little closer, like this is between 8 and 9. It's a little closer to 9, so I'm going to go with 8 point. Is it 8.6 or 8.7? That's a good question. I'm going to go with 8.6. Let's see. 6 times 6 is 36. 6 times 8 is 41. Plus 3 is 51. 6 times 8, 48. 8 times 8, 64. 68. 6, 9, 13. 73.96. Whoa, that's dead on. All right, so 8.6. We have units here, which I've sort of neglected. And so it's approximately, right? It's an irrational number. It goes on forever, but it's approximately 8.6 centimeters. That red diagonal. FC. Oh, should I label it FC? Line segment FC. All right, so this is the ladder who's leaning against the wall problem. And what's missing here? Well, missing the leg of the triangle. So we're going to call this leg squared plus 7 squared equals 8 squared. So L squared plus 7 squared is 49 equals 64. Subtract 49 from both sides. And we get L squared equals, we're borrowing 15. All right, so L squared equals 15. So L equals the square root of 15. It doesn't say how to express your area. It's positive or negative, but so it's the positive square root of 15. Now, you can leave it that way, right? That's simplified. There's no 4, 9. There's no perfect square factor. Or you could realize that it's around 3.8 or 3.9 feet. One of those. Right? Because square root of 16 is 4 feet. All right. All right, so now, I have neglected to say, so I've been using L squared plus L squared equals hypotenuse squared. The traditional way, and the way you're probably going to see it elsewhere, is A squared plus B squared equals C squared, where they define A and B as the legs. And I say it's easier to use L for legs. Now, the problem with that is that there's 2 legs, and so you'd have a L1 and an L2. But I found, I learned that A squared plus B squared equals C squared, and then I was always trying, you were easily trickable if they changed the letters. And I didn't want you to be trickable to change the letters. I want you to know what the legs are and the hypotenuse are by definition. But anyway, in here, just the traditional way, the legs are A and B. Right? The legs are A and B. The hypotenuse is C. That is the traditional way to teach this. So 8 squared is 64. 12 squared is 144. 15 squared is 225. 64 plus 144 is 8. I'm getting 208. 208 equals 225. That is no good. All right, so it's not a right triangle. It's less than. So the less than, which one does that one go with? Oh, go back and look at your notes. Yeah, it's obtuse for less than. Final question. All right, once again, we're going to use the converse or the reverse of the Pythagorean theorem. So again, there's the traditional ABC, where the legs are A and B. So we're going to square the square root of 28. We're going to square 6, and that has to add up to C, which is 8 squared. Square root of 28 squared is 28. 6 squared, 36, that's 64. 28 plus 36, 14, 64 equals 64. Yep, this has to be a right triangle with those legs. All right, good luck on the homework.